somewhat like this. Microbes. Bacteria evolved to survive on a planet with 1% of Earth's atmospheric pressure. An arid world where temperatures can plunge to 220 degrees below zero.
The upper surface is so nasty. That doesn't mean that just a little ways under the surface wouldn't be a much happier place for microbial life on Mars.
Is there life on Mars? Just a decade ago, my answer would have been very different than it is today, because we've learned so much.
A few decades ago, it would have seemed like science fiction. But we now know that on Earth, some bacteria cluster around thermal vents at the bottom of the sea. Others thrive in pockets of liquid water inside 12 feet of Antarctic ice.
Our knowledge of microbial life on Earth has increased so much that I think, there's still a good chance that some kind of primitive life may have formed on Mars and existed there at some point.
How could life have first formed on Mars? Maybe with a flash of lightning. The spring of 2006. Even as some scientists are claiming Mars doesn't have lightning, Earth-based microwave detectors find it in friction-filled storms of red dust.
But it's not lightning like we know it, associated with rainstorms. It doesn't rain on Mars. It's what's called dry lightning.
And this dry lightning, or static electricity, could have been the trigger for Martian life.
Once you have lightning, you've got a new source of energy that can affect your chemistry and alter things in the atmosphere, even on the surface at some level.
A famous experiment seeking to replicate the creation of life on Earth ran an electric current through a mix of water and common gases, creating a soup containing organic compounds and the building blocks of life, amino acids.
By hitting things with electrical discharges, you could not necessarily generate life, but maybe make the preconditions for life.
But did dry lightning help jumpstart life on Mars? Or did it kill the chance for any life at all?
Lightning on Mars could create things like hydrogen peroxide, which could then lead to other chemicals that would destroy organic material and sterilize the surface.
Life-giving jumper cable or fatal electric chair? The jury is still out on what dust storm lightning has done to Mars.
Well, what always happens with Mars is about the time we think we understand it, we discover new things that make us realize we still have a lot of mysteries to solve.
So how do you find bacteria, too small to be seen, living under the surface of a planet 48 million miles away?
The life that's most likely to be prolific, the life that you find the most number of organisms, if they did exist, is the one that's hardest to find of all.
Like climbers, scientists look for life on Mars by making connections, linking this observation to that deduction, hoping the evidence leads in the right direction. And if the facts aren't there, you start over.
It's hard to look for life. So the mission designers have said, well, let's first figure out if there are habitable places, if there are places that would be friendly to life.
And the key element for life as we know it is water.
On Earth, liquid water is required for life. Even if it's a small pocket in the heart of a glacier, you still need the fluid nature of water for the processes of life to take place.
According to early space probe photos, Mars was just a dead red rock. Its thin atmosphere was mostly carbon dioxide. And so it seemed were the polar ice caps.
You know, in the 70s, we might have expected that there was no possible water or life on Mars. The picture is much different today.
In the 21st century, more advanced space probes have revealed that a lot of the earlier information was wrong. It turns out there's about 100 times as much H2O in Mars' polar ice caps as in all 5 of North America's Great Lakes.
So even in the polar caps today, there's probably enough water to cover the surface, about 20 or 30 feet deep. But it's really not about whether we think there's water on Mars, but whether there's liquid water on Mars.
That's the key question, because even microbial life could not have evolved on Mars unless there was liquid water early in the planet's history.
In order to find liquid water on Mars, we actually look in a whole variety of ways.
From 1997 through 2006, NASA's Mars Global Surveyor searches for water-based minerals using a highly sensitive spectrometer.
Every chemical element has a particular signature associated with it, a sort of fingerprint. And when light interacts with it, it re-emits that light in a very specific way that's characteristic to that given element. And so that's telling you what things are made of by just looking at the light they emit.
It's similar to the way the human ear can pick out specific vibrations.
Some notes boom out. Other notes are not so loud.
This is over. And then, bang, giving birth to an endless expanding existence of time, space, and matter. Every day, the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. Where are the Martians? On the red planet's poison-packed surface? Or in newly found sources of water? Did Martian life survive an apocalyptic attack? Are Martians microbial or monstrous? At last, the answers are here. In Mars Evidence.
I believe we can send humans to orbit Mars and return them safely to Earth. Mars will follow.
When we land on Mars, there may be billions of Martians waiting for us. Only they probably won't. Or this. But like this. Microbes, bacteria evolved to survive on a planet with 1% of Earth's atmospheric pressure. Degrees below zero.
Now, even if that upper surface is so nasty, that doesn't mean that just a little ways up